to be able to sketch the graph and the behavior of the sine and cosine function without a calculator or Desmos. And certainly, I just wanted to remind you and let you know that at any point to check your work or to kind of maybe look at other things, you can always graph them on Desmos and or your graphing calculator and kind of check your answers. But the goal is to be able to do these without the assistance of technology. Okay. So we want to first look at the parent function of sine and cosine. And so when I think about the sine function, and I'm thinking about it like on let's say the unit circle, remember the sine function follows the y variable. So what I'm doing is I'm just putting on the 4 quadrantal values, and I'm just going to plot those 4 quadrantal values, but I'm only going to think about the y coordinates. So for thinking about the y coordinates for the sine function, I'll switch to my highlighter here and maybe go to the little blue here. So the y value at 0 would be 0. The y value at 90 degrees or pi over 2 would be 1. Back at 0, or sorry, at pi radians, I'm sorry, is 0. And then at 3 pi over 2, it's -1. So I want to sort of keep track of those values on the graph. So at 0 radians, I'm at a height of 0. At pi over 2 radians, I'm a height of 1. Call that 1. At pi radians, I'm back to 0. At 3 pi over 2 radians, I'm at -1. And at 2 pi radians, I'm at 0. So it gets and since we're moving in this counterclockwise direction in a very smooth way, it's a very smooth wave, right? Very aesthetically pleasing. It's so balanced. That's actually, I'm really impressed with myself. It's hard to do on the screen. And since you continue to go around and around in a circle, the graph of the image is going to be identical. So if I would have drawn a period of the graph over here, I will come down to -1, up to 0, and then up to +1, and back to 0. So that's what we call the sine wave. And for our sine wave, I'd always like to have several periods drawn, and a period just represents the amount before I repeat myself. So in a standard graph for sine, the period is 2 pi because it takes us 2 pi radians to go around one revolution. We'll change the frequency of our graphs, and so if you've got a physics background, you know that wavelength and frequency have an inverse relationship to each other. But the other thing I want to talk about is the amount we deviate from the line of equilibrium. That's called the amplitude. And in a normal sine wave, and we'll find a cosine wave is the same, their normal amplitude is 1 because I'm deviating 1 unit above sort of this line of equilibrium, this line of balance. Okay. Now, cosine is going to look really close to the sine wave. The difference is that it has a different starting point. So if we think about cosine, remember cosine of x, y equals cosine x, it follows the x coordinate. And so coordinate. So if I follow the x coordinate at 0 radians, I'm already at the height of 1. And then if I go over to pi over 2 radians, I'm at 0. When I go to pi radians, I'm at -1. When I go to 3 pi over 2 radians, I'm back to 0. And when I'm at 2 pi radians, I'm back to 1. So it's going to look, again, just as smooth, just as balanced, but then we just have a different starting point because cosine of 0 is 1. And so we draw a period on this side, and it's exactly the same wave shape other than we start at our maximum amplitude. So just like sine, a cosine's graph has an amplitude of 1, and just like sine, the period of a standard cosine wave is 2 pi. Okay, so we need to know those basic shapes, but then also realize that sine and cosine are identical in wavelengths because notice you can identify a sine wave right here. Oops, I didn't mean to erase it. I can identify a sine wave right here within the cosine graph. Look at that. It's a sine wave. And guess what? There's a reason because of exactly what we're studying right now, cofunctions. I mean, think about the power of that. That we could say that sine of theta equals cosine of 90 minus theta, right? So you're just rotating or shifting things to the left or right 90 degrees or pi over 2. So every sine graph is really a cosine graph that's been shifted, and same thing with the cosine graph is a sine graph that's shifted. Okay, so let's take a look at what happens when we start to alter things within the function. So when you have a coefficient in front of your sine function or cosine function, that affects the amplitude. So that means that you're multiplying your outputs all by 4. So rather than having a height of 1, sine will have a maximum height, in this case, of 4. But it's still going to have the general shape, right? So you can say, okay, well, sine of 0 is 0. Sine of pi over 2 would have been 1, but now I'm bouncing it up to 4. So height of 4. Sine of pi is back to 0. And then sine of 3 pi over 2. So I want to mark these here. 3 pi over 2 is negative 4. 1, 2, 3, 4. Sine of 2 pi is back to 0. So I want to make sure that I keep track of my quadrantal values labeled and also my amplitudes. And then when I draw this, I go up to the 4, back down to 0, negative 4, and back to 0. So again, it's going to look very similar. We could go ahead and draw this wave. It's just been vertically stretched because the amplitude is 4. And I want to mark on this side too, this is negative 2 pi as the period. This is negative 3 pi over 2, negative pi, and negative pi over 2. Fantastic. Okay. So coefficients in front affect the amplitude. Also, if you notice, we've got a coefficient of not just a 3, but a negative 3. So if you remember back from first semester, we're going to have a reflection over the x-axis. So instead of drawing cosine starting at 3 because of the amplitude, so instead of doing this, which would have been the cosine without the negative, right? So instead of doing that, we're going to reflect that image over the x-axis. So we are going to start instead down here. So we go up to there. So the green graph really is our graph. And we're just getting that nice smooth, as soon as it said smooth, I didn't make it smooth, cosine wave. I like to start from the left and go to the right. And then we want to make sure we label. So we're labeling a height of 3 and negative 3. And then since we didn't really change our period, I'm still going to mark off our quadrantal values of 2 pi, 3 pi over 2, pi, and pi over 2. I'd like you to do that at least on the right side. On the left side, certainly you can go every other one. I just want to make sure you're indicating your units of measures. Okay, so now example 3, we just have a cosine wave that has a positive coefficient of 3. So our amplitude is affected by 3. But notice this minus 1. That's going to pull everything below 1 unit. So I'm going to mark that our new line of equilibrium has kind of dropped 1 unit, right? So I'm 1 unit below. So now when I draw my cosine wave, I'm going to treat this dotted line as my equilibrium. So I'm going to go 3 units up from the line of equilibrium. So I'm actually at 2. And then 3 units below the line of equilibrium would be negative 4. And if you take a real quick peek here, your span from 2 to negative 4, that has a distance of 6. That span is always twice the amplitude. So your span is 6, 3 above, 3 below. 1, 2, 3. Except for I wrote it right. You guys are all yelling at me in the videos, as you should, because I got carried away. Let's go back to the real negative 4. 1, 2, 3, 4, which is right there. Okay, so 1, 2, yeah. So, but now our cosine wave will start up here. There's the equilibrium. there's the lowest, there's equilibrium, there's the highest. And I do like to draw those 4 dots or those 5 dots and then draw your wave. All the waves are really going to look the same. It's just like, how are they labeled, right? So maybe you're already picking up on that pattern in that sort of, that's excellent. Okay, so we draw our wave coming down. Oops, I kind of missed my spot. Coming back up. Okay, so, and again, label, like it's important to label. So this is 2 pi. This is 3 pi over 2. This is pi. This is pi over 2 because I haven't changed my frequency. And then at least here, call that negative pi and negative 2 pi. So just maybe trying to do a little anticipation. You know, we've seen that if you put a coefficient in front, that affects the amplitude. We've seen if we put a coefficient right there, that sort of affects our line of equilibrium. But if you notice our sine or cosine wave, like if I did not have that -1, I'd still have the same shape. It just would have been shifted. Oops, if I can, there we go. It would have been shifted up, back to the line of equilibrium. So adding or subtracting certainly lowers our cosine wave. So what changes frequency? Well, what haven't we affected? And I'm guessing, bingo. I'm guessing that's you put a coefficient, right? You put a coefficient in front of the x. So that affects our frequency. So when you have a coefficient in front of your x, this tells me that I've got a twice as fast frequency. Oh, I had a pen here. There we go, wake up. So this right here is representing frequency. You can tell my pen is super slow because that word looks nothing like frequency. I promise that's what I wrote. Frequency. Okay, so erase that, erase that. So we want frequency. Right, slower maybe, I guess. I don't know. Maybe like in a dead spot. Okay. So if my frequency is twice as fast, that means instead of taking 2 pi radians to get around one time, I'm gonna go twice as fast because I'm gonna get 2 of those waves in that same interval. So I'm gonna take 2 pi, which was our normal period, and I'm gonna divide by 2 because I'm going twice as fast. So in other words, it's only going to take me pi radians to get one time around. But the image of the sine wave is still going to look the same. It's still it's still going to start at 0, go up to 1, go back to 0, go down to -1, go back to 0. So I'm going to still draw that sine image like that. And same thing on this side. And you'll see what I'm doing here in a second. So my computer got really slow all of a sudden. So if I draw this sine wave, the only thing that's really going to be different is how I label it. So the height is still 1. This is still -1. But since it only is taking me pi to get around once, because again, my frequency is 2x, I'm going twice as fast. That means when I get here, that's already pi. So that means this distance here is half of what it usually is. So that's pi over 2. And since we're dividing it into fourths, half of that would be pi over 4. So that's pi over 4, pi over 2. This right here, is going to be 3 pi over 4. And then this is pi. Because again, we have quadrants, right? So another way to think about that is, well, your period is pi, divide pi into quadrants. That means divide it into quarters. Okay, so we can do the same thing on the left side, right? We'll label this as negative pi. Oops, sorry about that. We'll label this as negative pi, and then that's a quadrant, and then this could be negative pi over 2. And so even though it's going twice as fast, we only have to write one period on one side and show one period on the other. Okay, so this concept of doing 2 pi over b, 2 pi over what I'm calling b, where b is the frequency, this is going to help us find the new wavelength. Find new wavelength or find the new period. Okay, so it's just 2 pi over that coefficient. So it might look awkward that I have pi over 2 as a frequency, because that's, very irrational. However, if I take 2 pi and I divide it by the frequency of pi over 2, it actually comes out to a nice wavelength, because you would multiply this 2 pi over, right? The pi's cancel, the 2 comes up, and we get a wavelength of 4, which is excellent. So I'm going to just make this a little bit bigger. So I'm going to call that 1, and I call this -1, just so I have a better graph there. So my cosine graph starts there at the top. It comes down to here at the equilibrium. It goes to not -1. It goes there. It goes to +1. I definitely suggest mapping out the cosine wave first. Draw the curve, right? So we draw this nice cosine wave, and then go back and label afterwards, because the labeling really reflects your frequency, right? So if I think, okay, my new frequency is 4, so it's taking me 4 units to get there. That means half of 4 is 2. This is 1. This is 3. How nice is that, right? Super nice. And then we know this is -4, and then, it's quite a nice frequency, or quarters there, -4, -3, -2, and -1. Okay, so again, same idea here. We have this negative in front of our sign, so that negative is going to reflect over the x-axis, but then also this 1/6. So think about, I have 2 pi is my period, and I'm dividing by 1/6 as the frequency. So that means that's going really slow, right? Think about that, 1/6, that's fast. In other words, that's going to be 12 pi is going to be the new wavelength. So I'm going to, again, just for a better way to see what's going on, call that -1, call that +1. So sine is going to start at 0 like it always does, but I'm going to go in the negative direction because of the negative coefficient in front. So there's -1, back to 0, back to 1, back to 0. So again, just trying to get a nice image here of this sine graph. Draw it very smooth, aesthetic. Now, some people try to get lazy and try to make that pointed. Please don't do that, right? It's a curve, it's a circular function, okay? Very nice. Now, we go back and we label, because we knew our new period was 12 pi. So 12 pi, and then we just divide that into quadrants. So that's 3 pi, that's 6 pi, that's 9 pi, there's 12 pi. And then here's -12 pi on that side, and we knew that was a marking, and we call that -6 pi. So that's sort of what I'd expect. I mean, it doesn't have to be super colorful like mine, but certainly that's something that you should be able to be sketching these very, very clearly. Okay, so let's look at what happens if we have lots of things going on, right? So we already know the 3, right, affects the amplitude. We know 2 pi is going to affect the period. So this 1 x plus 1/4, it's sort of like when you're graphing quadratics. If you had x minus 4 squared plus 3, and I asked you to graph that, well, you would say, well, I would move this to the right 4, 1, 2, 3, 4, and up 3, and there's where the vertex would go, and I draw my parabola. So what's inside the x is a phase shift, moving things left and right. Well, that's exactly what this is going to do. It's going to move things left and right. So what I would suggest to do is factor out your coefficient, which it is, which is great, and then let's look at what is happening with our different coefficients. So we know the amplitude is 3. So I'm gonna go 1, 2, 3. So I know the amplitude is 3. 1, 2, 3. There it is. Okay, and I know with 2 pi, if I do 2 pi over b, and my frequency is 2 pi, so that's 2 pi over 2 pi, which is 1, which is kind of cool. Okay, so that means my new period is 1. So what I'm going to do is I'm just going to think about cosine without the phase shift for just a minute. So cosine starts at 1, 0, comma 1. It goes to 0. It goes down to -1. It comes up to 0 and goes back up to that one right there. Same thing coming here. So this would be our cosine graph exactly without the phase shift. Kind of ends like in a W there. Okay. So this is 3. Oops. Sorry about that. This is 3, and this is -3. Okay, so now, if I knew my, oops, I keep doing that. I knew my period was 1, so I know that this over here is 1, and then that divides into quarters, right? So that's 1/4, 1/2, 3/4, and 1. And then this could be -1/2 and -1. So think about that's actually an excellent quarter marking because we're shifting it to the left by a quarter. So it's done nicely, right? So the graph is going to really be shifted to the left by a quarter. So what I'm going to do is I'm just going to just trace on this through the magic of Smartboard for this first one. And then I'm just going to shift that to the left by a quarter. Now, notice some of my graph over on the left, like it goes off the page and I'm missing some things. I just wanted to see that image. I'm shifting to the left by a quarter. So when I'm actually doing that, and I'm going to graph it, so I might say, okay, so this point goes to here, shifting to the left, and then I just start my cosine wave. So, or I could say this point shifts here, this point shifts to the left, this point shifting to the left, and then there would have been one here, to shift to the left there. So, and then the same thing, there's one here, and one here. So we get this beautiful sine wave that's actually upside down, but it's at least in the sine wave's position. So maybe you're already thinking, well, my goodness, I could have given you a problem that had negative sine and would given us that exact same image. And you're absolutely right. Okay, so I appreciate your patience. If you need to pause this, to stand up and do a stretch break, feel free. Or if you want to try example 8 and 9 without me and then try, and fast forward, that's fantastic. Okay, so I'm going to go ahead and do this. So my amplitude is 2. So 1, 2. Actually, I'm going to call this 2 because I want a bigger graph. So call that 2. That's 1. I just want to enlarge it. That's 2. So -1, 1. Okay. I have a frequency of 4. So it's 2 pi over the frequency of 4, which is 2 pi over 4, which is pi over 2. Okay. So, and it's normal sine. I don't have any negative reflections. So I'm going to start at 0, 0 at the equilibrium marking. I'm going to go up to 2, back to equilibrium, down to -2, and back to equilibrium. So I'm drawing my sine wave, drawing my sine wave, drawing my sine wave. Remember, it's everything except for the phase shift, right? Going up to here. Oops, sorry about that. And then going back down to here. Okay, so now let's see, well, what are these quadrantal markings? If my period is pi over 2, which I had gotten from dividing, 2 pi by the frequency, so this is pi over 2. We divide that into quarters. So this is 1/4 of pi over 2, which is pi over 8. This is 2 pi over 8, which is sometimes better known as pi over 4. This is 3 pi over 8. And this is 4 pi over 8, which is pi over 2. And look at that. Again, nicely done so that I'm shifting to the right by exactly a quadrant mark, which most of these will be. Okay, so then let's take a look at graphing this. So moving it to the right, each point. So I'll pick this nice blue. So I'll make this one's to the right, and then this one's to the right, and this one's to the right, and then this one's to the right. This one was to the right. Then this one's to the right. This one's to the right. This one's to the right, and this one, there it is, to the right. So we get, looks like a negative cosine wave because we're shifting to the right by 90 degrees. And then I'll go ahead and fill in this side. So when you're doing these on homework, and I got a little pointed, I apologize. when you're doing these on homework, you're gonna want to somehow indicate like what's the right graph, or if there's any kind of stages in between. So somehow highlight that this one is the right one, or dot the other one, or make it light. But I do want to still see the graph, right? I still want to see it. And then on the other side, we should oops, not highlighter, my bad. On the other side, we should probably mark that this is negative pi over 2. Just pick a different color, Mr. Brown. Negative pi over 2. And then this would be negative pi over 4. Okay, I believe there's one more. So you guys have been doing fantastic. So again, thinking about, I see this equation. There's nothing in front of sine, so I know there's a 1. It's amplitude of 1, but I'm just going to make it a little bit bigger. So there's 1, and there's negative 1. And then my frequency is pi over 2, so I do 2 pi over that pi over 2, which gives me a wavelength of 4. So then I'm going to draw my normal sine wave. So it goes up to here, nice and balanced. And some of you, are going to get really good at these. They're kind of fun to do, I think, but sorry about that. It's kind of dorky. Just nice and smooth and, balanced, a very aesthetically pleasing graph. Okay, so that's the sine wave. I kind of made it dotted because I haven't shifted it yet. So labeling a frequency of, or a period of 4, we divide that to quadrants. And then -1, -2, -3, -4. And you'll see our phase shift follows some of our quadrant values. We're shifting it 2 to the right. So I'm going to take my graph and move it 2 to the right. So all the points will be 2 to the right. So that first wave would have been this. And then as you kind of complete your graph, you kind of pick up the pattern. So 2 to the right is almost exactly, actually it is exactly a negative sine wave. Okay, so again, maybe make it a little bit thicker, I don't know, or highlighted, but that is your sine wave for your final graph. Okay, so a lot in that video. And again, the whole goal is to help us analyze the sine function, the cosine function, know about frequency, amplitude, phase shifts, and do them by hand. Okay, excellent. Very, very good.